A second test of general relativity was not based on observation that had already been made, but it was based on making an observable prediction from the hypothesis. So if general relativity is true and space and time are both stretched out, the deeper you go into a gravitational well, then it should be observed that clocks closer to the center of the Earth will run slower than clocks that are high up. And we actually can test this today because we have very precise time measuring instruments. And we also have clocks that are very high up above the Earth. And those are clocks on board satellites. And so if you remember when we talked about special relativity, because these satellites are moving relative to the surface of the Earth, we actually need to take the effects of special relativity into account when we build our global positioning satellite systems. Well, we also need to take general relativity into effect because these clocks are much higher up. They're not as deep in the gravitational well of the Earth, and so they are not affected by the warping of space-time as much, and their clocks will run faster than ours. And those need to be taken into account as well when we're adjusting the clocks of our global positioning satellites.
Because of special relativity, they gradually fall behind clocks in Earth-based receivers at a rate of 7 microseconds per day.
After Einstein formulated the theory of special relativity, he went further ahead and he proposed his theory of general relativity, which is not only a theory of space-time, but it's a gravitational theory.
Key to Einstein's theory of general relativity is the fact that gravity alters time. Clocks farther away from Earth, where gravity is weaker, run faster than clocks closer to Earth, where gravity is stronger. The GPS satellites are located 20,000 kilometers above Earth, where gravity is much weaker than on the surface. Due to general relativity, satellite clocks run 45 microseconds faster daily. When we combine the effects of special and general relativity, satellite clocks run 38 microseconds fast every day. This may not seem like much, but if uncorrected, all GPS measurements would be off by 11 kilometers daily.